I'm going to come back again and summarize of the things that we've done. So Shiv mentioned about the deterministic system design, right? As you saw, the entire bill of material is automatically created. There's no product catalog. There are no 50 different access points, 2 by 2, 3 by 3, 4 by 4, and 900 different switch form factors. You don't have to choose any of those product catalogs. You don't have to deal with any of those things. And no dedicated hardware at each site. That is, hey, smaller, mid, or large, what we call Nile Service Block, a Lego block. Frankly, and as Shiv said, it comes in multiple shapes and forms, that is small, medium, large, or we call t-shirt size. And you can use it for small remote location as well as branch location or the campus wide, where you can put them together to grow scale as much as you want. And then, more importantly, as we said, shift left, moving all the challenges that you have in the day one and day two to the hardware and software design. And as part of that, we eliminated complete configuration. This is not zero touch, it's a zero configuration. A lot of people think it's a zero touch configuration coming from the cloud. Absolutely not. It's a zero configuration. Neither customer nor partner nor Nile configures any of the network elements. We do not have any control ports. We do not have any CLI. We do not have web UI to configure the network elements. We do not have any, and even for the physical sensors, virtual sensors, what out there, you'll see 30-page document to configure a sensor today. In our case, absolutely zero configuration. That sensor has a QR code. You scan the QR code and you place it in the, as part of the mobile app, you place it in the mobile, wherever you want on the floor plan, and it's up and running. And it uses certificate-based authentication to connect to the network. And then not just the network elements, not just the sensors, but network protocols. As we were talking about earlier, the fabric, absolute zero configuration. Nobody is configuring the protocols. And then the other one is quality of service, advanced quality of service, traffic forwarding rules. All that is also automatically get taken care. We have the deep packet inspection, we have the device fingerprinting, we have the built-in quality of service. Frankly, we built hierarchical costs in the past. We gave the best practices. So based on the applications, based on the, we can identify more than 3,500 applications, and we know what's required for each application. We automatically forward it, and that's the determinant. So whether it's a small site, medium site, or large site, whether it's a higher education, it's a K-12, it's a warehouse, across all of our customer bases, we have the same network design works across all of these deployments.
Does the customer have the ability to customize? What if they have an application that's not one of your 3,500 identified?
Sure. So first of all, we do monitor customer applications as well. And customer has the ability to configure the application signature, for lack of a better word. And we have built-in mechanisms. We know whether it's a voice, whether it's a video, whether it's a data application, or some are real-time, not necessarily conferencing, but real-time applications that they need to. So in those cases, they do have that access. And the next one is zero trust security. We talked about, right? And Shiv was talking about many of these things. First of all, the hardware. As we said, it is being built. To be more transparent, it's built in Taiwan and it's being shipped to the customer site wherever it is. But when we are building the hardware, every box has a TPM, just like in it, but it has a unique certificate. As it's coming out of the manufacturing line, it talks to our cloud, provides its information, and we create the certificate. We download the certificate. Entire software is signed using that certificate. And the next one is the control plane. Since you're delivering the service, you're not really controlling the environment. If someone were to snoop the traffic, what happens? The control plane, management plane, data plane, entire thing is encrypted by the hardware. So no impact to the performance of the user traffic. And then next one, as he was talking about, someone could walk in, connect to the Ethernet port, and in our case, it's completely locked. If you have a printer, if you try to remove the printer and connect it, you're not in the printer VLAN. You need to get authenticated. By default, every device and every user is denied. And again, there are no VLANs, no static VLANs, absolutely based on the user identity, based on the device identity, only then you can get onto the network. And once you're on the network, go ahead.
Is it only data plane on-premise? Is control plane all cloud-based, or is it both?
Sure. So control plane, data plane is local. Okay. Because even earlier, as he was asking, when the internet goes down or the connectivity to the cloud goes down, and what if there is a link goes down? The entire resilience is built within the Nile Service Block. So control plane, data plane is local. Only that AI fine-tuning, the closed loop automation is in the cloud. Make sense? And then Once you are on the network, every user and every device is isolated from each other. Frankly, these days, when you're on here, there's no reason to be connecting, talking to each other device directly. Almost all your applications in the data center or in the cloud or on the internet or the SaaS, because of that, the east-west communication is extremely limited. And the only reason that happens is, frankly, lateral movement of the malware. We eliminate complete lateral movement of the malware. But if you do need to, you can say that Tom and other delegates can exchange Windows update or iOS update. Only those applications are allowed to talk to each other within the building, or IoT device to IoT device. Here, the applications that they need to talk to each other, you can enable only those applications, right? And then, to your question, sensors are continuously verified. They're looking at the entire environment. And more importantly, once you're on the network, what's the guarantee? It's you. You got authenticated, but what's the guarantee? As part of the Zero Trust, it's not just identifying and authenticating authorization. You need a continuous authentication, continuous authorization. So we have built-in post-stop security principles. Probably most of you know dynamic ARP inspection, DHCP snooping, unicast RPF, or reverse path forwarding. We verify all of this to make sure that nobody is spoofing your identity even after you're on the network. And then when you think of the security, it's not just about the security in the network, but also security in the cloud. We do know who are all the devices, users that are connected to the network, what applications they're accessing. We encrypt the entire user identity, and you can bring your own keys. And using your keys, we can encrypt that data in the cloud. And when we talk about the data, we're not talking about the actual user traffic is not coming to the cloud, just to make it clear, right? It's only the IT tracking information, like who is connecting to the network, what devices are they connecting, what applications, for debugging, troubleshooting purposes only, right? And then, we are going to be launching soon, but one of the things is about microsegmentation. We've been talking about it for years and years, and we have not realized it. So we have microsegmentation that allows you to authorize only the applications that you want between the users or the devices, or user to device. Then the third one, again, just summarizing what we've been talking about. In order to do autopilot or autonomous network, you need to collect the data from multiple systems. So we talked about physical sensors that you just saw, right? And we have a similar sensors, the radio, dedicated radio. Many of you probably understand the wireless very well, where if you have a radio that's serving the clients as well as monitoring the Wi-Fi, it's going to have impact on the end user experience. We eliminated those challenges. We have a dedicated radio that is also monitoring just like a physical sensor, collecting the data and sending the information to the cloud. And more importantly, we also have deep instrumentation into every aspect of what we do. Then another thing we have done, Tom, typically comes at 8 o'clock in the morning and stays until 7 and comes back on 5 days a week. And when you do software upgrades, any kind of changes over the weekend, typically you tend to do over the weekend, but we do many other things in live. But if you're doing over the weekend, when it comes back on Monday, how do you know is the experience improved or not? So we look at every user and device as a sensor, giving us the information, and not just the current snapshot, but also historical information. So every change we make sure that every end user device experience improved. And then in the interest of the time, not only monitoring the network itself and monitoring the environment, we also monitoring your DHCP servers. We monitor your DNS servers. Because how many times have you heard Wi-Fi sucks, network sucks, when your DNS server is down, when you cannot access the Facebook, when you cannot access an application, first thing comes is network sucks. And almost all our customers said mean time to innocence. Network is guilty until proven innocent. How fast can I show to my rest of the peers, IT teams, that network is not at fault? So because of that, we monitor radius, DHCP, DNS. We go even extreme. Let's say, Tom, you're getting onto the network. Your certificate is going to expire. We're going to tell you in advance, Tom's certificate is going to expire 30 days from now on. Otherwise, you come in, your certificate expired. First thing, Tom, you're going to blame the network, right? So we avoid those kind of issues happening even well before they happen. Then on top of that, when you think of performance, you also have to think of latency, and you have to think of other aspects of the performance. We can't continuously monitor and continue to fine tune the service.